Hey, okay, so this video, excuse me, this video is teaching you guys how to do equations, how to represent equations using symbols, geometric shapes, things like that. A visual thing, if you will. Why bother doing something like this? Why even have an assignment over this? Well, different people learn the same thing in different ways. Because if there was just one way to learn something, then somebody would have written a book, publish it, and we're off to go. But God made us different. He has made us different, and He's given us unique gifts and talents. And because God likes variety. So because people learn in different ways, this is another way for people to learn how to represent this. So you have a paper that can be downloaded on my WCS. There's a number of them you're going to do, except number 9. Okay? Now, here we have an equation. I'm going to do 2 examples with you guys. This is from number 4 on your paper. So the 4 with the parentheses is not part of the equation that we're looking at here. So we got a time-honored equation here. And what are we going to do? How can we sit there and represent this? Well, I'm thinking, all right, I first need to think, well, what shapes am I going to have? Well, I know I have to have the hydrogen. How am I going to represent the hydrogen? You know what? I'm going to have the hydrogen be represented with a triangle. Okay? Does it have to be a triangle? No, it could be a square, it could be a circle. It's up to you how you want to represent it. You're using a shape, a geometric shape for this. Okay? And if I'm looking at oxygen, so oxygen, I need to have that represented with something too. So I could do a circle or a square, and in this case, I'm just going to go ahead and I'm going to do a square, like this. Okay, so it's not the perfect triangle, not the perfect square. That's okay for what we're going to do here. So we have 2H2 plus 1O2 gets us 2H2O. Okay, you might recognize that paper of something that I had you guys do earlier in the course. We were balancing chemical equations. Okay, so I need 2 of these H2s. Well, what is that going to look like? Well, if one triangle represents one hydrogen atom, then I can have 2 triangles represent 2 hydrogen atoms. So I have one H2 right here. I can draw another one like this. So I have 1H2, 2H2. So I match that. Now, remember, the idea is to represent an equation, a balanced equation. Instead of using letters, we're just going to go ahead and use shapes. That's our main goal. And it's important to balance the equation. Well, why? In nature, you have to have the balancing of materials, the balancing of each kind of atom on both sides, from before the chemical reaction to after the chemical reaction. If you don't have a chemical reaction, you wouldn't have an equation. You wouldn't have a need for this. Okay? So we have one O2. All right. So I'm going to represent the O2 with 2 blue boxes like this. Now, do you have to have your shapes colored? That's up to you. That's just a preference thing. Okay? So I have my 2 H2s. I have 1 O2. And remember, the arrow means this will result in, or this will yield. So I'm going to go ahead and I'm going to have 2 H2Os. So I know that this oxygen breaks up into 2 separate pieces. I know that these hydrogens also break up. Now, how do I know this? Well, because here's one water molecule like this. You say, that's a funny way to do a water molecule. No, it is just showing using the shapes that we have. This is our visual here of what the molecule looks like. Okay? So this is it. I have 2H2 plus 1O2 gets us 2 H2Os. Here's our 2 H's right here, our red triangles. Here's our O, and we have our second one here, 2H, that are our red triangles, and one O. That's it. Okay? So it's easy as that. Let's try another one. This one, there's a couple of things I can think of right away, and I noticed that I have got three things. I have KC, oops, no, let me erase that, sorry. Let's try that again. I have K, I have CL, and O. That's just the warning bell for first period. Okay, my favorite class is coming in, so you'll have to excuse the noise level. Anyways, so here, if you look at it, you kind of notice, do you notice how KCl is one piece here? It is also one piece here. Now, that can make things a little bit easy for us, because instead of doing a separate shape for the K and a separate shape for the Cl, why don't we just say it's one shape that describes the KCl? I think that would make it a lot easier. So I'm going to go ahead and I'm going to represent a green box as our KCl, and I'm going to have a blue circle represent our oxygen. Okay, I'll write it out. Oxygen. So that's what we have, ladies and gentlemen. So I have 2 KClO3 gets us to 2 KCl plus 3O2. Well, what's going on here? Well, we've got a reaction where we are breaking something down. This is a decomposition reaction. Okay, so what's that going to look like? Well, I know I'm going to need KCl, and I'm also going to need another KCl here. So I know I'm going to have 2 of them because they told me that. Now I have got 3 oxygens. Okay, so I'm going to put 1, 2, 3, like that. So here's my KCl and here's my O3. And over here I have KCl with another O3. So I have 2 of these KCl's and O3s. Now keep in mind, I also pointed out which shape represented what. That's a very important thing that you have to have. So here's what we got. Here's potassium chlorate, and we're now breaking it down. We're decomposing it. We're breaking it down to 2 of these KCl's. Well, we said earlier that the green box, the green square, represents KCl. So this is what we have. We have our 2 KCl. Now we have O2s. Now the thing is, notice that we have 3 of these O2s. Okay, so how do we represent that? Well, how's that? Does it matter which position that these are in? No, no it doesn't. As long as you are consistent. So this is one way that might help some people to balance equations. This is a way to help people visualize what's going on for balancing equations, or even in the stoichiometry. We had 2 KClO3s. Here's our KCl. Here's our O3. We have 2 of them. It breaks off into the 2 KCl's, and then we have 3 of these O2s. We have 1, 2, 3. And we have our 2 KCl's here. Okay, guys, so that should do it. Remember, big tip, if you got something that's at the reactant, on the reactant side of the equation, and on the product side of the equation, you can do that as one shape, one unit, because they're not breaking apart. Okay, hey, I hope this video was a benefit to you guys. And take care and God bless.